Where do you want to deploy UDLD? You want to deploy it on every single fiber optic connection. It's designed to protect you from unidirectional links on fiber optic connections. You might as well use it. But what is the best way to deploy it? UDLD aggressive mode. It's going to give you the best protection. Why? Well, with UDLD aggressive mode, it will it'll try up to 8 times in 8 seconds to reestablish the UDLD neighbor. And if that fails, it places the ports in the air disabled state. And since the ports end up in the air disabled state, you are protecting yourself from spanning tree loops as well without UDLD even knowing it. Now it says here to turn it on in global configuration mode to avoid operational errors and misses. Yeah, do that for the fiber interconnections. But remember, if you are using UDLD for copper connections, you will have to use aggressive mode in interface configuration mode to accomplish that. What about our spanning tree protocol features, such as loop guard, root guard, port fast, and BPDU guard? Well, here's a great exhibit as to where you should enable these features. Notice loop guard is being enabled pretty much everywhere within the topology except for those interfaces that are running root guard. Because if you enable loop guard on the interfaces that are running root guard, then root guard gets disabled on those interfaces. So be mindful of that when you're deploying loop guard. Root guard, in this case, is being deployed in a strategic location, and this location is specifically determined because we never want these ports to become root ports. Never become root ports, because root ports point to the root bridge. Is ASW ever going to be the root bridge? No, it's not. Do we ever anticipate a rogue device connected out this interface to become the root bridge? No, we don't. So by implementing root guard on those interfaces, we ensure that no device down in this area has the ability, let me redraw that, no device down in this area at the access layer has the ability to become the root bridge and destroy our spanning tree topology on us and cause suboptimal traffic flow or potentially capture some packets because of the way the traffic is flowing now through the environment. When it comes to port fast and BPDU guard, right down here on the interfaces that connect to the end stations, and really these two features work together. They are tightly integrated features. You enable port fast on the interface for a couple of different reasons. Number one, to transition that interface to the forwarding state as quickly as possible, but it also suppresses the sending of topology change notifications or topology change in BPDUs when that interface goes up or down. Without port fast enabled, you have an excessive number of topology change messages that are generated for no reason because these are insignificant changes to the overall spanning tree topology. So port fast is a feature you want to use to improve convergence and reduce the amount of BPDUs that are generated in the topology due to these interfaces coming up and down. And then BPDU guard is the protection mechanism. It's that stability feature that ensures that if a BPDU is received inbound on any of these interfaces, the interfaces are placed in the air disabled state to protect the spanning tree topology, because the last thing we want is a rogue BPDU to change our spanning tree topology, because that BPDU is superior to what we are currently using in that topology. So it's going to protect our port, protect our spanning tree topology, keep it stable, and make sure that they are placed in the air disabled state if that BPDU is received.